Hello everyone, this is TechWiz. In this video, we will be discussing about cyclomet. Cyclomet is basically the solution proposed by us to solve the problem statement that is put forward by ISRO, Indian Space Research Organization, during the Smart India Hackathon 2022. So, talking about the problem statement, it basically says that we need to develop or build a deep learning model, basically a convolutional neural network model, which will be predicting the intensity of cyclone by taking into consideration the images or the live images which are captured by INSAT. INSAT is basically the satellite of ISRO itself. Talking about the solution, we have basically developed a deep learning model or a convolutional neural network model which is predicting the intensity of the cyclone or intensity of the image which we are giving it as input, and the predicted intensity on the other hand is displayed using a website. So as we can see in the flow chart, first of all, the images which are captured by INSAT-3D, they are retrieved through API call. The collected images are then image processed. Once the feature extraction or image processing is done, 80% of the images are used for training purpose, while 20% is used for testing purpose. The train images are then annotated and fed into the deep learning model or the convolutional neural network we have built, while the test set are directly fed into the deep learning model. And after passing it into the deep learning model, if it is found out that the annotated area is less than the threshold, that means there is no threat, that means there is no cyclone. So our website will be giving a message that there is no threat, and will be also displaying the live satellite image. On the other hand, if the annotated area is found to be greater than the threshold value, that means there is a chance of a cyclone or a threat. So we'll be moving to the next step, that is the intensity prediction. And for predicting the intensity, first of all, we will be predicting the wind speed using histogram matching. Once the wind speed is predicted, the next step is very easy. From the range of wind speed, we basically need to find the category of the tropical cyclone and the intensity it is falling in. So once all this is estimated, we'll be basically displaying all this, the wind speed, the intensity, the category of tropical cyclone and the live image of the cyclone through the website, and we'll also be giving an alert signal that there is a chance of potential threat. So talking about each of the steps in details, the first and the foremost part, which is the dataset collection part, the live images that are captured by INSAT-3D satellites, they were retrieved. For demonstration purpose in this presentation, we have taken two images. We can see first one is the cyclone image and the second one is the no cyclone image. This is what the satellite image captured by INSAT-3D looks like when there is a cyclone approaching, and this is what it looks like when there is no cyclone. So we collected this data. The data set collected was then image processed because we need to extract the important features. While extracting important features, we tried eliminating the noise, eliminating the land area through erosion, and to regain some of the important features which were lost while carrying out erosion, we dilated those images. So this is the output which we get after image processing. This is what our cyclone image looks like after getting image processed, and this is what our no cyclone image looks like. So once the features are extracted, we'll be then passing these images into our model. Our model is basically a convolutional neural network. So this neural network, it distinguishes the low pressure region by converting them into violet color, while the background it turns the background into yellow. We can see the major difference. In case of cyclone, the percentage covered by this violet area is much more as compared to that when there is no cyclone. So moving forward, what we need to do to find out whether a particular low pressure will be developing into a cyclone is, will be basically comparing the percentage of violet or the percentage of low pressure with the threshold value. So if the percentage of the violet is greater than the threshold value, that means there is a chance of cyclone, and if it is less than the threshold value, that means there is no cyclone. So since the area was found to be 20.69, which is much more than the threshold value, so we can conclude that there is a chance of cyclone over here, and in case of B, there is no chance of cyclone. So since there is a chance of cyclone over here, our next step and the foremost important step next is calculating or estimating the intensity. And for estimating the intensity, first of all we need to predict the wind speed. So for predicting the intensity, we first of all need to predict the wind speed. The wind speed in our case is predicted using histogram matching. What we are doing is, in our case, the test image is the cyclone image, which in the previous slide showed that there is a chance of cyclone or there is a chance of threat because the area was found to be 20.69. So that image, we found out the histogram points of that image. In our case, we had taken the funny image as our test, while the rest of the cyclones we included them in our training data. So what we'll be doing is, we'll be finding the histogram points of the training data and we'll be comparing like which one among the training data has the histogram points which has maximum correlation with the test image. For example, if it is found out that the second row has the maximum correlation in terms of histogram points with our test image, then the wind speed, which is in this second row, will be assigned to our test image. So using this principle, using this concept, we found out that the wind speed of funny or the test image was found to be 115 kT. So once the wind speed is found out, the next step is very easy. We just need to predict the intensity and the category of cyclone by looking into this table. Since the wind speed was 115, we can conclude, or our model says that cyclone funny must be in this category and it must have a T number or intensity in terms of T scale, which is T6. This is what our model predicts, and this is what Google says about the funny cyclone, that it is an extremely severe cyclonic storm. Thus we can see that our model very accurately it is predicting the category of the cyclone or the intensity of the cyclone, and we can conclude from here our model will be able to predict the intensity even when the cyclone is in its initial condition, because we are taking into consideration here the percentage of area covered by the low pressure. So this is what our website looked like when the funny image was passed into it. It was shown that there is a danger, it gives an alert message that there is a threat, and it gives the wind speed it predicts and the intensity in case of in terms of T scale. Moreover, we also have a time lapse video which helps us track the movement of the cyclone. On the other hand, this is what our at the present moment there are no threat. When this video is being recorded as of March 29, there is no threat over here. So this is the live satellite image, and this live satellite image, when this live satellite image of this live satellite is passed through our website, it is showing that there is no threat and the wind speed is normal and the intensity is normal. So basically our website will be collecting these live images, and if there is a threat or if it is detecting that there is a chance of cyclone, it will be trying to predict its intensity and showcase that, and will also make a time lapse video of by starting to collect those images, if a threat is detected. But if there is no threat, this is what our website will be appearing like. So talking about the use case, this can be used by any organization, by the state government or by the central government. First of all, the organizations will be receiving an alert notification from the website, that is there is a threat, and they will be receiving it in the initial condition. So the last minute rush could be avoided, because this method can be used for predicting the intensity even when the cyclone is in its initial condition. So the government will be receiving the cyclone notification, and it will be very very soon it will be starting the rescue mission. As soon as the low pressure is formed, will be predicting the intensity, and then will be initiating the rescue mission. On the other hand, the common man who will be having access to this website, they can also take the necessary safety precaution. They can themselves visit a website and see what is the status of the cyclone, which will increase awareness among them, and this will this will lead to less collateral and livestock damage. So basically, talking about the dependencies, our website is very budget friendly. Like it's a free website. Anyone with an access to mobile or a laptop or a desktop or a net can view this website. What we need is basically the satellite images which are captured by INSAT-3D, and this website will be hosted using AWS server. So it can be proven here that it's like economically our project or our ideation is also friendly. Talking about the tech stacks that we utilized for deep learning, we have for model building we have made use of deep learning or the convolutional neural network. Then we used Python scripts for various purposes, starting from dataset collection to annotation to the calculation of area for finding out if there is a threat or not. Then image processing so as to extract important features. Then HTML, CSS, React.js, Node.js for building the website. MongoDB for dataset. APIs were also used for image collection. Then the whole website was hosted in AWS. So that's it. That's all for our project. Basically, our project aims for predicting the intensity by reducing the human interruption, by making use of AI or the deep learning or the latest technology, and also it aims to predict the intensity when the cyclone is in its initial condition, and to make a one-stop platform where the details about the cyclone can be found out. So that's it. Thank you.